So Ashley, this is a continuation of our discussion about question 9 in your homework today, where we're asked to determine the observed t given this set of data and the decision we would make as a result of obtaining that t. So to do this, we need to calculate a t-test statistic. And the formula you've learned to use for that t-test statistic is to take b sub 1, your sample slope, which in this case we can clearly see is equal to this number in front of the x, 0.162. Subtract the claimed slope, which in a hypothesis test with regards to linear regression and its slope is always 0. We always claim there's no relationship between these two variables. And then we have to divide by the standard error of our slope. And the standard error of our slope, I was rather surprised when I saw this tonight, is a rather tedious calculation. So first we have to take the standard error of our residuals, which we calculated in a few of our problems together this evening. And in this case it was given to us, 3.94. And we have to divide by the square root of the sum of our x squareds minus the sum of our x's, then squared, divided by n. So I've created a little table over here where I've listed all of my x's, 12, 21, 28, 8, and 20. And we need to calculate the value of each of those x squareds. So we need to take 12 squared to get 144, 21 squared to get 441, 28 squared to get 784. And again, we can get the help of Excel on these. 8 squared to get 64, and 20 squared to get 400. What we need first is the sum of our x squareds. So if we calculate the sum of all those numbers we just calculated, we find that that sum is equal to 1,833. We also need the sum of our x's. So if we add up all of our x coordinates, again with the help of our Excel, these add up to 89. So now on to calculating the standard error of our slope. First it says, take the sum of our x squareds. The sum of our x squareds is this 1,833. Then the formula says, take some of the x's and square them. So the sum of our x's is this 89. We have to square that number. And then it says to divide by n, and n is the number of ordered pairs that we have, and in this case we have 5 ordered pairs. So if we calculate what we get when we divide 3.94 by the square root of all that stuff, we find that we have a standard error of 0.2498 if we round that to 4 digits after the decimal point. That's our standard error of the slope. Now, to find our t-test statistic, we have to use the following formula. So we need to take our b sub 1, which is the sample slope, and we can see from the equation given to us in the problem, our slope is the number in front of the x, which is our 0.162, minus the claimed slope, that's our beta sub 1, and in a hypothesis test for slope, we typically claim that the population slope is 0. That says there's no relationship between these two variables, no linear relationship. And then we divide by the standard error of our slope, which we found was equal to 0.2498. So when we calculate this, we will have our t-test statistic, which comes out to be equal to 3.182. Basically what that's saying, Ashley, is that if we have a set of variables, x and y, that have no relationship whatsoever between them, no linear relationship, then the probability, or then the then the relation, that the slope we got for the relationship between our sets of variables was more than 3 standard deviations above 0. So if we were doing a right-tailed test, this tail would represent what's called the p-value. Now this question I did not feel was worded very clearly. It did not clearly identify whether or not it was a one-tailed, a right-tailed, left-tailed, or two-tailed test. So there's the possibility that our slope could have been 3.182 standard deviations below the claimed value. So the combination of these two tails represents our p-value. So now, I'm not sure how you've done this in your classroom yet. So now what you have to do is try to determine, okay, given this test statistic and the fact that it is a two-tailed test, do we have significant evidence to reject the null? So I'm guessing that you've learned how to use a table of critical values for the t-distribution. And so what you have to recognize is that we have n equal to 5 ordered pairs, so n is 5, and typically our degrees of freedom for simple linear regression is n minus 2, which in this case would be 3. So we need to come down here to this row of our table of critical values that has a degrees of freedom equal to 3. Then we have to recognize that we're doing a two-tailed test, and our level of significance given to us is 0.05. So that means we find our critical value by identifying where the row with 3 degrees of freedom intersects the column with a two-tailed cumulative probability of 0.05. And we find that that value is equal to 3.182. So now what has to happen is we have to compare our critical value, our observed t-test statistic, to our critical value. So if our observed t, and we observed a t-test statistic of 0.65, if that is further from 0 than our critical value, which we got to be 3.182, we reject the null. If it is not further from 0, and in this case it is not, it's less, then we fail to reject the null. So our conclusion here would be to fail to reject the null hypothesis because our observed t-test statistic is not further from 0 than the critical value we obtained from our table. So I hope that helps. I will, if you have any questions about that, Ashley, please don't hesitate to message me. I'll try to talk you through it. But again, I'm rather surprised you have to do this TDS calculation on your own, but it is what it is. So hopefully that helps to explain what you need to do here.